Alright guys, this is part 2. We're starting at question 20, multiplying. So we just got to distribute our numbers right through here. And 8 times 3 is going to give me 24. X times x is going to give me x squared. And then the y is going to be sitting on there. And then this times a negative 1 is just the same thing, but it becomes a negative x, 8xy. Okay? 21. Multiply. When we multiply this, we like to set up using the box method. Okay, so for this one, I like to use the box method here. Helps me organize my information. I'll get 5x and 4, and 2x and negative 3. And then I'm going to just go ahead and multiply in. 5 times 2 is 10, and x times x is x squared. Then we get negative 3 times 5 is negative 15, and then x. 4 times 2 is 8, and then x. And then negative 3 times a positive 4 is a negative 12. We want to combine the like terms that I circled. They both have the same denominator, or not denominator, variable at the end, so we can combine those. We get 10x squared minus, so 8 minus 15x. We're going to actually find the difference between the two of them. That's going to be a 7x, and then we get negative 12. Okay? There it is. All right? So 10x minus 7x minus 12. Okay? Okay? So, okay, 22, we're multiplying here. We can use the box method. The only difference is our box is now going to become a 2 by 3 box. Okay? So it's the exact same principle. It's just a bigger box. That's it. X to the third, 5x, 2, 5x, and negative 3. So here we go. Multiply. I'm going to go kind of quickly through here. This is going to be 5x to the fourth. This is going to be negative 25x squared. And this is going to be 10x. Notice the coefficients multiply, the numbers in front multiply, and the exponents are adding. So x and x to the third becomes x to the fourth. Down here we get negative 3, x to the third, positive 15, x, and negative 6. Okay, we want to combine all like terms that I see. The only like terms I see are 15 and 10x. So we're going to write this out in the correct form, starting with our highest exponent, 5x to the fourth, followed by negative 3x to the third, followed by negative 25x squared. Getting along, and then we're going to do 10x plus 15x is going to give me a positive 25x, and then minus 6. So this is a very long polynomial right here, but we took care of it and made sure everything's looking good. Okay. All right, our next one is another multiplying. We're going to go ahead and use box method here as well on 23. So the only difference is it's squared. A lot of students want to distribute the square to each. That is wrong. So if you think the answer is this, I see kids that would write this as an answer. Okay? That's wrong. Don't do that. Okay? That's not how we do this. We have to set up the box method. Okay? Always box method. The only difference here is we're just going to get 6w and 6z for both spots. Okay? And we're going to multiply. So if you know this one's wrong, don't do that. Okay. So 6 times 6 is 36w squared. We get 36wz, 36wz, and 36z squared. We get that common term. Notice they're always kind of right there in that diagonal. And we're going to get 36w squared. This is going to become 36 plus 36, which is going to become 72 wz, and then we're going to get plus 36z squared. Okay, so notice very different answer between the wrong and the right. So here's the right way to do it. Do not distribute that square. That's not how we actually solve this, because if we did that, we'd miss out on the whole middle term. This middle term would be gone. Okay. Now, this next one, 24, we're going to do box method again, but what we're going to see is we're going to see the middle term disappear, because this is called, or this is a version of what we call DOPS, difference of perfect squares. You'll see what happens when I do this. But again, box method, r and 7, r and -7, and we get r times r is r squared. We get -7r. Up here we get +7r. Then 7 times 7 is -49. Notice the -7r and the +7r, they're going to cancel each other out. And I'm just left with r squared minus 49. The reason why I said DOPS is because this is DOPS right here. It's the difference of perfect squares. Okay, notice the difference sign is with the negative right here. They're both perfect squares. R squared and 49 are both perfect squares. Okay. So that's why we call that one DOPS. Okay. Number 25, it says find the area of a rectangle if it equals x minus 8 and the width of x minus 4. We're just multiplying. This whole page is just box method. We should be masters of this by now, huh? We get x times x is x squared, -4x, -8x, and -4 times a -8 is going to give me a +32. Write that out. X squared, these combined, that's -12x plus 32. Okay. Again, my common terms, my like terms, I have to combine them together. Okay? It's 1051 in case you're wondering. Alright? Okay, flip it, rip it, and rip it. Okay. Here's another one. We're finding the area of this guy for number 26 here. Same thing, box method. I'm getting tired of these box methods. How about you?
Yeah.
Alright, so let's do this one very quickly. X squared, 2x, -6x. This is going to be -12. X squared, minus 4x, minus 12. Okay. Oh my goodness. Okay. Very quick. Number 27. Finally, something new. GCF, the greatest common factor, is what we're looking for. What number goes into both of these? Preferably the biggest number that goes into both of these. Okay? Now, if you have a calculator, you can actually help yourself out a lot in this situation. I'm looking at this, and I'm seeing a couple numbers shout out to me. One of the numbers is 12. Okay, I know this would break down to 12 and 4, and I have a feeling 72 might break down into 12, and it does. Okay? Is this my greatest common factor? Okay? We could potentially have a larger one. Okay? So 12 might not be the greatest common factor we have here. What's another number that might sound good? Anyone know? Okay. Let's try it out. I was thinking maybe 24. I don't know. Divide them both by 24. And I'm thinking 24 might be better. So sometimes you got to try a couple times. This would be 24 and 2. And this one's actually 24 and 3. So the greatest common factor is 24. So 24 is my answer. That's a bit of trial and error. The good news is on multiple choice, we'll have all the options there.
Yeah.
Yeah, so you can just take each one and see if it fits into the numbers. Take the biggest one that fits into both numbers. That's your best bet. All right, moving along, we get to 28. We're finding the GCF here. Now this one's a little easier because the 2 and the 32, we know the GCF is going to be 2. 2 fits into both. M to the 5 and M to the 4th. What's the most I can take out as far as M's go? M to the 4th. You basically take out the lowest value that you see, that you can take that out. So there's my GCF. Okay. All right. 29. We're factoring here. We're going to go ahead and pull out anything we can using GCF. So I notice that they all have a y, and they might be all divisible by 3. Let's try pulling out 3y from each of these. So I'm going to actually divide each of these by 3y. And whatever I have left over, I'm going to put in. Okay. 12 divided by 3 is going to give me 4. Y to the 3rd divided by y is going to give me y squared, because I'm taking one of the y's out, right? I have y to the 3rd, so I take one y out. Over here I'm going to get plus 11y, and over here I'm going to get minus 2. Does it look like I can pull anything else out of here? Negatory. So this is fully factored for what we want to do on that problem. Okay, we're just practicing pulling out a GCF. So this was GCF. Okay. Number 30. Okay. Here we get an X factor. Okay, very important that we put the multiplication number on top, the add number on the bottom. What two numbers multiply to give me a positive 10 but a negative 7? Well, I can only think of one answer, and that would be negative 2 and negative 5. Okay. All I'm doing is factoring, so I get x minus 2 and x minus 5, and we are done. Okay. The way we taught you this before was to split that middle term, right? Okay. That's going to happen. We're going to save that for the problems where we don't have a 1 in front of my x squared term like I do for 30 and 31. All right, so 31, again, we have x factoring. We get 27 and 12. Got to think of numbers that would go into 27 and 12. I'm thinking 9 and 3 might do it. And you guys would all agree with me, I'd assume.
Yes.
Thank you for the support, one person. And there we go. Okay, so x factoring, once you get the hang of it, pretty quick, but sometimes takes a little bit of time. Okay. All right, we got x factoring, sorry, for days here. Here we go. Let's go turbo mode here. Negative 48, negative 14. All right. Ooh, this one's tricky. I got negative up here, so I got to do a negative and a positive number. So I got to think, what would be 14 spaces away from each other if I were to do this? Okay. So I'm thinking, maybe what could potentially have 14 spaces away. Thinking maybe a smaller number. Also, I'm thinking it's 1056, by the way. Thank you. What do we think? Let's see. We need a decently large number, right? Let's see. No.
So much for turbo mode.
Turbo mode just got shut down. Alright, we're going to turbo mode this real quick. Turbo mode. You see how I wrote those down like in 2 seconds? So fast. Not factorable. That happens. That's why turbo mode gets slowed down by some. Oh, we listed out all of our factors, and none of them are going to work within that space. So that's okay. So this is a good example of when we don't know what the answer could be. We can go with non-factorable as long as we list all of our factors out. All right. Let's see if we hit another non-factorable again here. Negative and a positive. What numbers are going to come out with a positive 7, negative? This one's a little easier. It's going to be 2 and 9. So that one was a little bit easier. Okay. X plus 9, x minus 2 gives me negative 18, but positive 7. Moving down. We get 16 and 8. What two numbers? I'm going to go with 4 and 4. This would be x plus 4 times x plus 4. Or we could write this as x plus 4 squared. Alright. Okay. 35. Now we get to the good ones. 35. We have to do the x factoring, but we change it up a bit. This top number is going to be 3 times negative 2. So this is 6. That was 3 times negative 2. That's how I got that number. And the bottom number is 1. Okay, the numbers that are going to hit that is 3 and negative 2. Right? This is where we're going to split that middle term. Boom. We get 3x minus 2x. Bring down the negative 2 here. Bring down the 3x squared. And then we are going to factor by grouping. It's been a long time, huh? Factor by grouping here. So I can pull out in this one a 3x. That leaves me with x plus 1. Over here I can pull out a negative 2. That will leave me with x plus 1. They look at the same. I'm going to miss that. And there's our final answer. Boom, boom, boom. Okay? Notice we factored by grouping, we split that middle term. This is a great